Hello, boys and girls. Welcome to our new set of notes here, Chapter 4.1, Graphing Quadratic Functions in Standard Form. So we're going to be graphing these in different types of forms. I am Mr. Dvorsky here, of course, with your notes. Things you're going to need: a graphing calculator, make sure you have that, and a pencil, and let's get started here. So, how do coefficients of a quadratic function affect its graph? First thing to write down here is the standard form of a quadratic equation. That is going to be y is equal to a times x squared, what? Plus or minus bx plus c. Pretty crazy stuff going on here. Anyway, what's going on? So a is just like before. It's actually going to tell us if the graph is opening up or down. So if it's positive, it's going upwards. If it's negative a, it's going to be opening downwards. Okay, an upward looking quadratic looks like this. Whoop. Downward is going to be like this here. Okay, so a is just up or down. If it's negative, it's down. Pretty straightforward. B, it tells us a few other things. The main other thing is C is our y-intercept. Okay, so for a graph that has a y-intercept of 5, it would be at the point 0, C. That is your y-intercept. The main things to know for that. B does a few other little things, okay? And we'll get to that in a moment. Graphing a function in standard form. Of course, our graphing calculators can help, but the main thing I am going to be asking you to do is find the vertex. All these problems are based upon finding the vertex. The vertex is the little peak or valley of the quadratic, okay? To find the vertex, this is your best friend, the x value of the vertex. You use the equation negative b over 2 times a. Negative b over 2 times a. Negative b over 2 times a to find the vertex. That's where our b value comes in. Okay, 2 times a. Negative b. So the x value of our vertex. Let's label some things out from our equation. First off, in front, a is going to be negative 1. Okay, there's a negative 1. That tells me it's going to be opening down. The y-intercept is going to be negative 3. So c is equal to negative 3. That means we have the point 0, negative 3. Now, to find the x value of our vertex, that is negative b over 2a. So I'm going to have negative 4, b is equal to 4, all over 2 times a, which simplifies to negative 4 over negative 2, which is positive 2. So that's the x value. Now you need to find the y value. So the vertex is a coordinate point, which means that in order to plot it, we need to substitute it back in. So we're going to substitute that back into the equation. Okay, so the equation is negative x squared plus 4 times x minus 3. We're going to substitute that in for x. So negative 2 squared plus 4 times 2 minus 3. Okay, this is where all of our stuff starts coming together. So negative 4 plus 8 minus 3. That's going to be 4 minus 3, or just 1. Okay, so the y value is 1, which means our vertex is both those combined. The x value is 2, the y value is 1, 2, 1. So now we have a few different things we can plot. Okay, we can now plot that vertex. Over 2, up 1. Over 2, up 1. There is the vertex. Okay, that is the highest or the lowest point on our graph. In our case, it's going to be the highest. Okay, something else we can actually plot that's not here is we know this y-intercept. Okay, we know it's going to cross at 0, negative 3. 1, 2, 3. So there's our y-intercept, our c value. To get some other values, this is where it's very helpful to use our graphing calculator. Use the old G-Calc. Okay, we're going to turn that on, go to y equals, okay, clear out anything you may have, and just type in the equation. Negative x squared plus 4x minus 3. I would use the table. So second graph gets you to the table. And what you want to do is you want to find the vertex, and you want that to be in the middle of your table here. So the vertex we know is at 2, 1. Now notice how it's kind of symmetric over in the window here. So 2, 1's our vertex. If we put that in the middle, x is 2, y is 1. We have some other values here. So we have 1, 0. We have 3, 0. And we also have 0, negative 3. And we have 4, negative 3. So it's this nice symmetric looking graph here. And we're just going to plot the rest of those points. I would like you to have at least 3 points when you're plotting. So we have 0, negative 3, over 0, down negative 3. Hey, we plotted that one. Over 1 to 0. Over 3 to 0. And over 4 down to negative 3. And now we're just going to connect the best we can. Okay, and that is our beautiful, beautiful looking quadratic equation. It is supposed to be a little bit curvy here, okay, but it should be pretty symmetric. That's the key. A few things with this here. This line down the middle, notice how it's symmetric. We call that the axis of symmetry. The axis of symmetry. And that is always going to be the x coordinate of your vertex. X coordinate. Coordinate. No, that's not right. Coordinate is the axis of symmetry. For example, our axis of symmetry is x equals positive 2. Okay, and it should be pretty symmetric. Okay, this side is about the same as the others. So the axis of symmetry and so forth. Alrighty, maximum and minimum. The thing with maximum and minimum, there's going to be a maximum if the graph is opening downward. So for negative a, there's going to be a max because it's opening down. And for positive a, there's going to be a min because it's opening upwards. Okay, that's basically the idea here. Maximum when it's opening down, minimum when it's opening up. The point that's used is the y coordinate of the vertex. Do it again, of the vertex. Okay, so if we look back to our graph, our maximum is at 1. Okay, the highest value it goes is at 1. Okay, so max min. Here are some great practice problems for you. I will pause it right here, or you can actually kind of go through with me. Okay, so if you want to try these in a little bit, I'll check them. Anyway, so I'm just going to get on started. Graphing the function negative x squared. Okay, first find the vertex, which is negative b over 2a. But Mr. D, there is no b value. Well, let's see. We have a is equal to negative 1. B, there is none, so that's 0. And c, there is none, so that's 0. Negative b over 2a, that's just going to be negative 0 over 2 times negative 1. Hey, that means it's at 0. Well, that's 0. How do we find the y coordinate? We're going to substitute that back in. So the y of the vertex is going to be negative 0 squared, which is just 0. Okay, so 0, 0. Boom. To find some other values, let's go to the graphing calculator. Y equals, clear that out, negative x squared. I'm going to go to the table. And here's my vertex, 0, 0. I want to get that in the middle. And I'm just going to plot some other points. So 0, 0 is my vertex. Negative 1, negative 1. 1, negative 1. And let's get some others. Negative 2, negative 4, and 2 to negative 4. Okay, so we have this here, and this here. And we have over 2 to negative 4, 1, 2, 3, 4, and there. And that is our quadratic. Isn't she pretty? All right. A few things again, just for the fun of it. The axis of symmetry is x equals 0. The maximum is also y equals 0. Okay, that's our highest point. All right, this graph here. So, vertex, negative b over 2a. Again, b, now here's the key thing. B always goes with the x value. There is no x value. Therefore, b is equal to 0. Okay, so again, we're going to have 0 over 2 times a third, which is really 0. Okay, so the x-coordinate 0. To find the y-coordinate, substitute it back in. So we'd have 1/3 times 0 squared plus 3. 1/3 times 0 is 0. So we just have 3 over 0, up 3. Now the graph's a little funky, so we'll plot it right about there. Note to self, this should be opening upwards. Why? Because A is positive. Okay. Axis of symmetry, so that's going to be there. Let's just go to the graphing calculator, type this in, find some other points. 1/3 x squared plus 3. Second graph. Okay, let's find some nice whole values. So 0, 3 is in our middle. I see negative 3 over 6, or up 6. 0, 3, and 3, 6. So we have all that going on. Over negative 3, 2, 3, up 6, 2, 4, 6. And there. Okay, if we wanted more, you can always get some more. Negative 6 and 15. Okay, that one goes too far. So there we go. Axis of symmetry is x equals 0. Minimum is y is equal to 3. Okay, the y value. Okay, so last two problems here, not too bad. Graphing the function, label the vertex axis of symmetry, that's what we've been doing. Negative b over 2a. Notice we have a negative 4 here, so it's going to be negative negative 4 all over 2 times 1, okay, which is 4 over 2, which is 2. All right, we're going to substitute that back in. So 2 squared minus 4 times 2 plus 2. That's going to be 4 minus 8 plus 2. 4 minus 8 is negative 4 plus 2, which means negative 2. There's our vertex. Over 2, down negative 2. Graphing wise, from there, you could plot the y-intercept, so over right there, or we can go to the table as well. Let's just see that it's there. X squared minus 4x plus 2. Delete the rest. Clear it out. X squared minus 4x plus 2. Second table. Okay, let's get the vertex in the middle. Okay. 2, negative 2. See how it's nice and symmetric? That's what we want. Over 0, up 2. Hey, we plotted that one. Over 4. 1, 2, 3, 4, up 2. And there's that one there. Vertex, right there. Axis of symmetry is x equals 2. Minimum is y equals negative 2. Okay, last question, find the minimum value. That just means to find the y of the vertex. Okay, so we don't need to graph this one, we just need to find the y of the vertex, which is negative b over 2a. So we have negative 6 all over 2 times 2, which is 6 over 4, which is 3/2. Now be careful, that's the x-coordinate. Okay, to find the y, we need to substitute that into the equation. So 2 times 3/2 squared minus 6 times 3/2 plus 6. If you're not confident with your fraction skills, use your calculator. 2 times 3/2 squared. Now notice, parentheses, minus 6 times 3/2 plus 6 equals 1.5. So y is equal to 1.5. As a fraction, that is also 3/2. Minimum value is y is equal to 3/2. Okay, awesome stuff. So hopefully you got those down. They're there for you in the back, or if you miss class, and use those in the future. So practice problems coming up, very similar to these. Nice stuff, guys. Awesome.